Welcome to qnawire.
In this question, we have a contraption with a pivot point O, connect with a rod of 120 millimeters long, connected to B here, and then it's connected to this rod AB that's 180 millimeters long. A is attached to a piston that is moving to the right at 2 meters per second, and we want to find the angular the angular velocity of OB. So the first thing to do is figure out what where the center of rotation is, and that'll be this C over here on the left, which we can find by looking at the directions of movement of VB and VA. We know that this length BC will be directly in line with OB, which lets us find that this angle right here is 45 degrees then. We can then find this angle up here is 30 degrees by knowing that AC into that velocity vector is a right angle. And then this final angle here, because all of the angles in the triangle have to add up to 180 degrees, this angle must be 105 degrees. So we have all of our necessary angles now. After we have the necessary angles, we can find some lengths that we will need. So we know AB, we now need to find AC, and then BC. So we can use the law of sine for this. The sine of 105 degrees divided by length AB should equal the sine of 30 degrees over length BC, which if we put all of our values in and put this into our calculator, we get that BC equals 93.2 millimeters. We can then do the same thing to find AC, so sine of 105 over AB equals the sine of 45 degrees now over AC, which again, doing the algebra, leaves us with AC equals 131.8 millimeters. So we have the two lengths that we need here. Next, we can find the angular velocity of the rod AB. So angular velocity of AB will equal the velocity of A divided by the length AC. It's just the radius of away from the center of rotation. So that would be our velocity was 2 meters per second. The AC we found was 131.8 millimeters. So when we convert these both to meters, that'll be 0.1318 meters. We find we get an omega of 15.18 radians per second. Once we have that, we can figure out what the velocity of B is. The velocity of B will just be the length BC times the omega AB, which we found BC to be 0.0932 meters. Omega AB is 15.18 radians per second. So we end up with a velocity of 1.414 meters per second. Then finally, we can find our angular velocity as the velocity of B over the length OB. So once we know what this VB is, which we got from our length BC, we can use our length OB to figure out what our angular velocity is over here for OB. And we end up with an angular velocity of 11.79 radians per second. And this will be in the counterclockwise direction going around O.